Well, good morning, everyone. Thanks for braving the rainy Houston weather to come out here for the first session of the day two. So welcome to day two of TechEd 2014. I think you've done the right thing by my estimation, because this is probably one of the few sessions at TechEd that actually focuses a bit on the hardware. And so I'll be talking to you today about Cluster-in-a-Box, what that is, and where it's going, as well as some interesting customer examples of how it's used. So welcome, and let's get going. So what I want to do here is tell you a little bit about the story of what this is all about. A number of you are very familiar with the strategy. A number of you, I think, may be learning about this for the first time. So I'll take a little bit time in the beginning to tell you about why we did this, what the goals were, and because it's a fairly far-reaching program that's been going on for about, well, almost 5 years now that we've been working with the industry to bring out these kinds of systems. And now with the advent of the cloud, it's some of the thinking and some of the strategy is starting to resonate a bit with where you guys are at. So I'll be able to tell you some of where we're coming from. There's been some new hardware released in the last year. This is probably, I guess, would be the third wave, maybe the second and a half wave of hardware that's coming out of these boxes. So they're not brand new. They're actually getting to be to the level of next gen. So for some people, they were worried about jumping onto something too quickly. Now we're in the mode where we believe the hardware has actually been proven, and it's actually an interesting deployment for a number of standard mainstream businesses, which you'll see in some of the case studies. And then finally, I want to talk a bit about, after the case studies, which I think you'll find some interesting things. I'm hoping it'll be something that will resonate with everybody in the audience in one way or another. Talk a little bit about the future. If you went to the keynote, you learned about everything about the cloud. But you also heard the message, I hope, if you went to, say, the foundation session on the future of the data center. I hope you got the message saying that the cloud's not one thing. It's not one thing to all people. In fact, I think you might have heard Jeff Woolsey mention when people say, hey, is the cloud this or that? No matter what they say, he'll pretty much say yes. And so when the cloud say, well, is it about moving all of your hardware to the cloud? Yes. Is it about modifying your hardware on-premise to deal with the cloud architecture? Yes. Is it about buying new hardware on-premise like you used to, but maybe with a different purpose? Yes. So this area here is about the hardware side. And so I want to tell you how it bridges all across. Now, just a quick survey. So how many people here actually are involved in the maintenance or installation of on-premise hardware? Yay, okay. I think if you look around the room yourself, you'll see the hardware is still alive and well in the era of the cloud. All right, well, let's get going. So, Cluster-in-a-Box. This is a part where I'll talk a little bit about strategy. So the idea was to bring availability to the volume market. I'll tell you what availability means, to tell you what the volume market means. So this has been a road, and I call the road from storage to the cloud, which is kind of a funny way to define a road. Storage, cloud, how are those endpoints of the same thing? But what we found was that availability itself was one of the key cornerstones that allowed hardware to enter the world that we're now thinking about as far as cloud architecture. If you think about it, there's a few things. If you had to go from standard server hardware to where we're at with talking about data centers and cloud, kind of the missing pieces tend to be things like availability, manageability, and scalability. So they kind of build on each other. And one of the things that became clear is if you didn't have a core level of availability, you really couldn't build anything as far as what we would typically think today as a basic data center operation, hoster operation of a cloud architecture. It has to stay up. People are concentrating lots of work onto something. And so where we started with this, though, was a little bit different. Because think about it, 5-6 years ago, we were still pre-cloud for the most part, or at least it was very formative. It wasn't the kind of thing people were just making plans to deploy. They were really just learning a bit about what it meant. And in that world, availability was really most applicable to storage, at least for Microsoft. So what we did there, we started by introducing really a software way to quickly bring up a cluster, this time focused on storage server. So we added the software to initialize a 2-node cluster, Microsoft Windows failover cluster, to make it real easy to deploy highly available storage. That was the problem of the moment, really the big gap that we needed to fill. But it was just a start. And so what we did then is that built. And then for Windows Server 2012, which has been kind of our signature rollout of the last few years, there was a lot of work done, huge investment actually, in the whole area of availability. And next slide coming up, I'll tell you more about what exactly we meant by availability. But in that release, we did a lot of work, years really of investment of large teams to scour the entire system from top to bottom, really. If you followed that story, you've heard stories of everything from memory management in the kernel. If you're going to be available, you can't fail when there's a single page block of memory that fails, all the way up to the initial release of some of the disaster recovery technology, which now today is grown into be Hyper-V Replica and the managed Azure services for Hyper-V Replica. So this was the kind of the platform start. This is also, by the way, is where we introduced some of the more mundane things. You can't be highly available if you have to bring your server down a monthly to introduce Patch Tuesday. So we also did the hard things. Hard sometimes doesn't mean technically hard. Sometimes it just means hard to pay attention to, but you got to do it, eat your vegetables kind of stuff. And that was, for example, automated cluster updates. So we had to introduce a way to do a rolling update into the cluster so that you could actually stay up on a regular basis, because it turned out most of the downtime that was required was planned downtime, and it was because of us. So from there, then we'd been working with our hardware partners because there was still a problem to solve, and that was how do you buy hardware and buy a system that's easy to deploy, that is easy to afford, and this is where Cluster-in-a-Box came in. So this was the strategy we'd been doing all along. It takes a while when you're working with the industry to come up with a new product. And so we introduced this. The first rollout of this really took about a year after the initial Windows Server 2012 release, and a number of partners by then had come on the train as far as producing this. The vision at the time, and still is really, is that wherever you went to buy a server, we wanted you to be able to buy a highly available one. And we wanted to give you the same choices as you have in today's servers. In other words, make availability a core foundational part of the feature set, not something special that you add on in certain cases. Now after that, it's been yet another year. And so we rolled out R2 last year, and we've come to kind of where we're at today, which is kind of a next gen. So when I mentioned this is no longer brand new stuff, that actually is good news, I think, for a lot of you who don't want to necessarily be on the bleeding edge of a new technology rollout or even a new system form factor. Today what we're seeing is next-gen feature sets coming out, and you'll see in the upcoming section about some of the new stuff that's actually released, just a lot of it actually in the last month or two, that a lot of new innovation is happening in the space. And so after that, well, work continues. And so this is the part I can't talk about, but I can tell you that we are definitely moving ahead in this space, and there's lots of things that we're basing for on-premise work and integration with the cloud. And in many ways, this type of hardware we see is kind of the new server. It's the new foundation that we're seeing will kind of become, we believe will become the on-premise standard. So that's the story of storage to the cloud. Now let me tell you a little bit about what we actually meant by this. So availability. Availability has a lot of meanings. A lot of you that have been in the industry for a while have been working with this probably for more than a decade. But the question is, well, why now? And I mentioned a little bit about why this matters now in my talk about when I mentioned the cloud and the expectations for availability, manageability, and scalability. Consolidation of servers, server virtualization is now, it's hard to argue that it's not mainstream technology. The concentration of VMs onto a single piece of hardware gives great economy of scale, great manageability. But it also, however, gives also great vulnerability. If one piece of hardware goes down today, you can lose an entire business worth of operation. So there was an increasing sensitivity to this in the general customer base. And that came across as a request for availability as a standard feature, even back when we were doing the initial planning for 2012, which really was 2008, 2009. So server consolidation is one thing. Another thing about consolidation is important is storage. Today, you can put an amazing amount of storage into a single box, hundreds of terabytes. Actually, if you had a chance to look at the DataON system up here, that 4U unit with 6 terabyte drives can actually hold up to 420 terabytes of raw storage capacity in a 4U box. Wonderful, again, economy of scale, great value, huge implication if you lose a piece of hardware today. So if you lose a server that's attached to this storage, you can now lose enough data to bring down fairly large businesses or organizations. It's a frightening thing. So this is why, again, availability of data has become paramount in most people's planning. Not a specialty case, not just for high stakes transactional processing, not just for specialty businesses that need to stay up 24/7, but actually just a standard part of a data center or hoster installation. So now, how do you summarize kind of what people want? Well, what people didn't come, when we did the surveys for this, people didn't come and say, well, what we want is a easier to use clustering technology with the following attributes. This is not the way people are thinking about it. People are actually thinking about it in fairly high level terms. What people wanted to do is keep their businesses running, keep availability of their data, keep their data safe. And in some sense, as we're seeing, especially the cloud architecture evolve, people are thinking in terms of an SLA. People are looking at this as saying, well, I want to be able to simply say that certain processes, if not my entire business, is up with a certain SLA of availability, of performance, and scale that I can, as much as possible, provide to my user base and not have to staff extra for it, not have to hire additional expertise to get, but I can simply mandate as part of my supplier. And supplier, in more and more these days, is becoming a cloud service. But when it comes to your own hardware, you're the supplier. You as being the people here that are involved in the IT administration, building, architecture of your own businesses. So for you, you're the supplier. You have to provide an SLA. And in some sense, that's the level at which people are thinking of availability. So this is what we were going for. And this is why it was new. Another thing people often wonder is, hey, I've been hearing about clustering availability forever. This is yet another box that does this. Why is this something different? And it's because of this new way of thinking, ease of use, manageability, making it a core and somewhat as close as possible invisible part of the system. That's the challenge that we had. And of course, sometimes it's a lot harder to make a technology invisible than to simply make it work. And so this was why it was such a huge investment to get this going. So what did we say we meant by continuous availability? Well, two things really. Basically, it said that you had to basically provide transparent failover. So the system, software and hardware, had to transparently fail over. And what do we mean by transparently fail over? Well, what we mean is that in the case of downtime, whether it's planned or unplanned, maintenance or a crash of some kind, that you had to survive that and not lose data. And it had to be something where you didn't get errors, you didn't lose data, you didn't get unexpected downtime. That's what we defined as continuous availability. And something we actually we use the term continuous instead of high as a way to emphasize that. As much as to the external world as to ourselves, that this was not yet another attempt to make it a little bit better than what we've done in the past 10 years, but actually a generational change. And we're trying to bring this to a marketplace that people could simply deploy. So a little refresher on the marketplace. So this one slide tries to sum up where things were. So about a little more than 5 years ago, actually, if you wanted to deploy high availability, you had two choices. And it was basically the two blue choices on the right and the left. One, you don't get it because you can't afford it and you don't have the expertise to do it. So just forget it. It's something that other people do. That was one choice. The other choice was on the right side, which was great if you have the money, if you look at the horizontal axis, the expertise and the budget to both purchase as well as deploy and maintain such a system. Lots of advanced choices, actually a huge feature set. These were your standard external storage arrays, SANs that had amazing features, all available to you if you could meet the requirements. And the trouble with some of this is it was even at the very beginning. You had to be fairly high in expertise to even know what to buy, let alone to put it together and deploy it. So a lot of times if you looked, for example, on server sites of even the big guys, you know, the large market leaders, it wasn't clear what you even had to license for the software, wasn't clear what equipment you needed. You really had to have pre-existing expertise to even make a plan to get the equipment. So this is what we were up against. This is why we introduced this middle category. The large green box was the problem we were filling with the industry to make available a cluster in a box. Basically, the idea was that we wanted to bring back the notion of a server with availability that was easy to deploy and really had all the same kind of choices that you had before. Turns out storage is one of the particular areas where we had to bring back some choices. So one of the things we did with 2012 release is we brought back a software RAID capability, a virtualization layer for storage called Storage Spaces. And so this is something now you could do something in the box as provide clustered storage. And we also work with the market leader in hardware RAID, LSI, and we worked with them to produce their Synchro CS product, which as it eventually was released, that brought you the market-leading RAID implementation now back as a clustered storage solution. So this was all part of the idea of making the same choices you had before with single node storage, simply part of the world of availability. This is what it takes to make a foundation across all the equipment. So this is what we did. And the other thing, of course, when you're bringing out a volume solution is you can't really just offer a toolkit. Imagine yourselves, while it may be technically interesting to see a bunch of features in a box, a lot of what people have asked for us has been, you know, what I really want is something that works. I just want a solution I can deploy quickly. I wanted to be able to depend on it. I don't want to have to spend a lot of time buying it or deploying it. And so it became, we had to work with our partners to target solutions to certain verticals, something that could be used and worked easily into a business. And you'll see some of that in the case studies coming up. So with that in the marketplace, we then had to focus on, well, what hardware are we actually talking about? And so the goals we set out with our partners in the industry were fairly straightforward. And these were not, one thing I want to make clear is a cluster in a box is not a specific blueprint. It's not a certain one-off kind of server that we dictated. Instead, we set up some fairly broad goals to match the customer requirements. So you can see availability. The basic requirement is you need to be able to survive a failure and its repair, and as simply as you can in the hardware. The rest of the details we kind of left up as value add from the individual partners as how they did that. Simple as possible was kind of the goal. That's why we wanted everything in one box. We found out that setting up a cluster typically would take a few hours, and then if you made a mistake, and typically mistakes were made in simple things as connecting the heartbeat connection for the network, to discover that mistake and repair it often took as long as the initial cluster installation. So as much as possible, make the box so that it installed as much like a regular server as possible. And then finally, we emphasize, hey, if it's possible, this is a broad-based market. So we like for choices to include office power, office acoustics, anything you can to broaden the ability to deploy these kinds of boxes, with the vision again being everything is available, everything's highly available. So in the end, the kinds of configurations that rose to the top were really configurations that, if you think about it, match a lot of what we're looking for in building data centers for the cloud. We want to use volume hardware, volume servers, volume storage solutions, and put these together in simple ways so that we don't have to be locked into specialty designs that are hard to maintain and upgrade. And finally, the other problem to be solved was how do we work with partners so that these are easy to deploy? Because while we've done a lot of work on the Windows side, there's a lot that we depend on partners to do to simplify the rollout. And so what we needed there was something that said, okay, how do you actually make a system powered on, easy to get up to usage in as few minutes as possible at the customer site? So first, the hardware. This is an example of what we were working with in the industry. This diagram actually shows a direct attached storage 2-node cluster. And so the kind of things we were talking about by putting inside the box was basically storage controllers and a crossover network for the storage to be able to be accessible to both nodes. So if you think about it, when you think about high availability systems, some of the things that really differentiate it are the ability to fail over, which means you need to be able to have storage that's connected to be able to be picked up and used by all the nodes attached to it. You want to have some backup, so you have to have some redundancy in the system. And so these are the kind of things that we worked with the partners to do. The requirements, again, a lot of the implementation was really all left up to the partners. We wanted the partners to bring their own expertise to the problem. So this is an example of what we worked with and eventually led to the kind of systems you're seeing in the marketplace. One key note here is that when you're looking at these systems for deployment, be sure to look at the insides. Make sure you understand, something about how it's deployed, something about the maintenance and serviceability, because all of that really is value add from the partners. And it varies quite a bit depending on what system you look at. In some sense, just like you would expect from your normal server providers today, which is something that I think we feel we ultimately is part of the success here, is that we have the range of choices that we were hoping for as far as what you'd be able to select for your own installations. And then finally, the last piece that we had is the software side. So while we've done a lot to provide an initial base, we provide an out-of-box experience, for example, here, that allows you to, from one monitor, set up a cluster. And we continue to augment this. In the last release from last year, we upgraded it to support up to 4 nodes. You can actually deal with the domain controller setup as part of it. So, however, this is customizable, and there's a lot you can go on from here. So one of the things that we worked with our partners is to educate them on the need for increasing the manageability of the deployment and even long term, and modifying this. This is all an XML-based setup, and so you can customize the look. You can add more initial configuration tasks. A lot of things you can do to make the deployment experience, power-on deployment, really easy. So you'll see from some of the vendors that they've done differing jobs, and I'll highlight some of that in some of the new hardware stuff. But a key part, hardware, software together, the system, and that's why it was so important that we work with a range of partners. All right, so that's the base strategy for Cluster-in-a-Box. Now I want to move on to tell you something about what's happened in the last year, and actually even in the last few months, about new hardware coming out. So with this, we have now some next generation boxes. So first, Dell has introduced. Last year, they actually released probably one of the more innovative examples of Cluster-in-a-Box. They took it not only to the level of 4 nodes, which they are able to do because they have a switched PCIe bus to let them share storage across 4 nodes, but also they did some research and actually introduced new sets of power and fan cooling technology to allow this to actually have office-level acoustics. So this is kind of an interesting box that lets you deploy even literally under someone's desk. A powerful 4-node virtualization server. This year, what they're introducing is they've kind of completed the picture by adding a redundant storage controller. So before they went out with a single storage controller, the redundancy was provided in the drives across it, but you still have that one point of failure. So now they've introduced in VRTX their additional PERC controller that can be added to provide redundancy down to that level, which kind of completes the picture for their overall redundancy. Everything else is doubled up as well. And you can see them, they actually have this at their booth on the Tech Expo floor. You can go check it out and see the insides. They have it available so you can kind of peel it open. Next up is something you may not have heard of, DataON. They're actually the ones that were kind enough to bring their new products down here for you to look at up front. So DataON, I think, is leading the market in terms of a product family of cluster-in-the-box systems, which is kind of nice if you have different requirements and you don't want to look at different vendors. So what they've done this time for their systems is they've upgraded them all to 12 gigabit SAS, as well as in their latest one, their 24-bay 2U box, which is right over here. This is also next-gen Intel processors. They're actually incorporating solid-state drives, working with HGST on incorporating those drives in. And then the larger one, which is the 4U box, they've actually qualified 6 terabyte drives, so you can actually get up to 420 terabytes of storage in a 2-node high availability server in 4U, which is pretty impressive. So they've also are working on, which should come out I think later in the summer, an upgrade management experience, which they're calling their management utility setup tool must. So they've listened to our call for value add when it comes to deployment and monitoring of these boxes. So I think both Dell and DataON have done a really interesting, innovative work to bring out a set of solutions as well as system solutions for deployment that make it very, very straightforward. And a couple of case studies will show that. A different kind of box that you'll actually also see on the show floor is from Violin. So Violin is known for high performance, basically enterprise quality flash storage. So they kind of reinvented the flash controller from the ground up, and that was their specialty. The interesting thing here is, and I think as they mentioned in the foundation session for the data center track here, is that a lot of these boxes really, the controllers, they're using quote-unquote controllers, are actually Intel-compatible servers. And so what they were able to do was to put Windows Storage Server directly onto their box, eliminating an entire layer of connection to their flash storage and providing extremely high-performance, enterprise-quality storage subsystem that you can directly plug into your Hyper-V workloads and mount, SMB3 folders and shares directly into your data center rack. So very, very interesting thing, and I have an example of that in the case studies as well. Supermicro is a name a lot of you probably are familiar with. This is, I think, a good example of what we were looking for when it came to broadening the market to wherever you go to buy servers, you have a high availability choice. So Supermicro is a great choice if you have interesting level of expertise, you just kind of want to buy some bare metal and deploy some systems. And so they've come out with a couple of choices, capacity and performance optimized, in this combined cluster-in-a-box form factor. So even for those of you that are looking to buy something more do-it-yourself, you now have that choice in a Supermicro box. Quanta, they were actually one of the first to deploy a cluster-in-a-box solution. You may not have heard of them, but you probably are using servers that were built by them. They're one of the original design manufacturers, ODMs, that supply a significant fraction of the server equipment in the world. They brought out and are shipping their own cluster-in-a-box. They've upgraded this year so that it actually has a number of interesting serviceability improvements, fewer screws, better access to drives, that kind of thing, as well as qualifying it on the latest R2 release. So again, next-gen platform from one of the first companies to come out with a release of cluster-in-a-box. And finally, I want to give an example of a company I'm almost guaranteed no one's heard of here. This is a company in Germany that actually is an OEM, but they're strictly for the German market. But they're getting enough. They got enough requests from the customer base for this kind of a solution that they decided to go ahead and brand their own cluster-in-a-box system and offer it as part of their solutions for vertical businesses in the mainly German market. So what we're seeing is the demand for this and the acceptance of this has now gotten to the point where it's becoming mainstream enough where most suppliers are actually either looking into it or offering this, and a lot of customers are actually simply doing proof of concept evaluations to see how it goes. So that's why I was really excited this year about being able to offer a number of case studies to specifically show what people are doing and what the results have been as they've deployed these kinds of systems. So 4 different case studies I want to walk through here. My guess is that somewhere in here it'll resonate with you, but we'll see. I think there's an interesting variety. So first up, this is a virtualization server example. I call it the case of getting things under control. So this was a partnership between a large public biotech company in Seattle and their IT provider, Aaron Marks, and they had the problem of upgrading their systems. So this is a fairly mainstream business. This is a company that does research for cancer-based cures, and so this is not a tech company per se, even though it's biotech, but their needs involved basically mainstream business with some of the specialty needs of a research lab. And on the next slide, I'll show you some of their workloads to talk a little bit more about what they were doing. But they had this problem that they'd accumulated a number of pieces of equipment over the last, really 4 to 10 years. And you'll see from the list of the kinds of things that you add on to your business to grow. And their problem was, they needed to upgrade it. It had become unwieldy, and they needed to do something. And they got to the point where they realized they wanted to do something more than simply incrementally upgrade each of the pieces they'd accumulated over the last decade. So they worked with Aaron Marks to come up with a new solution. So what were these guys doing? So this is what they were doing. Don't expect you to read all this. Don't jump on your chair and get your glasses out. This is just meant to give you a listing. This was a really nice thing that Aaron did, who's actually here, by the way, so you can ask him questions if you're interested in more details. And this shows the specific workloads. And you can see it's a combination of physical servers, virtual servers. There's specific workloads involving not only their primary everyday business, but also their backup, their ERP. They're running not just Windows workloads, but also open source Linux distributions. Their lab, as you can imagine in the research world, there's a number of pieces of software that are Linux-based that they had to support as far as research analysis in their lab. They had backup solutions, accumulation of servers from history, storage as well. And so you can see I imagine, so how many people here is this a familiar look to a rack that you might be involved with in your daily life? Yeah, this is sort of what you expect to see in a business that's been around for a number of years that's accumulated this. And the question is, where do you go from here? So one solution could be, well, you could incrementally upgrade each of these and look at the separate solutions, or you could think differently. And I think that's what happened here, is that with Aaron Marks, they thought differently about where they needed to go. So all of this then basically became this. And really became that. Turns out that in that picture, the lower box, that little 4U looking unit, is their old backup system, which because of Sarbanes-Oxley, they had their internal policy that required certain level of documented access to backups. It turned out easier to leave that piece of equipment in the rack than it was to change the company policy. So that will sit there for at least a year, I think, doing nothing. So basically, let me try this again. I just love this, the sequence of pictures. That to that. That's the kind of dramatic change that you can make that's possible with hardware these days. And if you look at what's done, they used the DataON, their CIB 9220. So it's a 12-drive unit. And what they did is they over-provisioned it a bit so that they used fairly large memory, I think 256 gig of RAM, so that they could host all of their workloads, both the physical server workloads as well as the existing virtual server workloads, on a single node in the case of failover. And so they gave themselves enough headroom where they could easily run their current workloads as well as additional. And in the case of a two-node system, but sometimes that comes up, you think about it, well, you have two nodes, and if you're running at capacity, what happens if you fail over? Do you really have the ability to continue your business on a single remaining node? So the solution here was simply to over-provision so that you could run the business on a single node if possible, if you had to, but during normal operation, you had just basically headroom in the two-node box. You can see they simply put all of their storage onto a single storage spaces pool using the tiered capability of storage spaces in R2, so that they were able to build up not only their system storage drives for their VMs, but also their backup storage onto the same set of drives and consolidate everything into the one box. So you can see it's a dramatic change. So the results. There's an interesting thing here that I actually hadn't considered until I talked to Aaron about the results here. This is SOX Sarbanes-Oxley requirements for actually how many people are involved in dealing with Sarbanes-Oxley compliance tracking? Yeah, it's a fairly standard thing. It was from one of the previous blowups, as you might remember, about in the industry that caused a lot of policy to be generated. Well, what they found was that going from a large number of servers and implementations in a single rack to this small single unit significantly reduced the overhead of producing compliance reports and even being able to demonstrate compliance, because they were able to show so many things were consolidated into single platforms that the overall, you can see here, the pages, I mean, just simply a factor of 5 in the report went down. So it's an interesting, for me it was unexpected. I hadn't thought about this part of benefit of simplification, not just in the operation, but also in things like everyday compliance, where you can really not only reduce the workload, but actually even make it feasible moving forward. Performance, as you can see here, I thought it was great to hear that Storage Spaces with their tiering solution provided all the performance they needed, and being able to slice up the drives in that single unit with enclosed storage in a single cluster in a box to provide their backup as well as main storage, as well as everything you need for the cluster, turned out to be just a big advantage to overall. So, and in the end, in the future expansion, this now has given them the ability, not only with their ability to manage the system, but also with the budget to allocate ideas and provide planning for add-ons. And being able to add a new server is now simple because they built in enough over-provisioning so that they can plan ahead for additional workloads without having to even change the hardware for a while. So interesting case example of how to move from the past to the future in a fairly mainstream business with a lot of standard needs as far as workloads. So definitely check out that list in the slide of workloads to get a feeling for for what kind of things are possible. All right, so case number 2. Another case of a virtualization server application. By this case, I call it keeping it simple. Emerson Process Management is a large operation, and their job is to introduce new automation systems into businesses. A wide range, you can see here, oil, gas, power, a variety of standard traditional businesses that have similar needs, though, when it comes to automating their process. And so their job is to both spec and deploy these systems. So their problem was they could do this. They could deploy a kind of Hyper-V virtualization server with storage in a highly available way, but it took a lot of time, it took a lot of space. And they were looking at, well, can this be something that we could use to simplify our job? And so let me actually have a short video from them that I want to play to give you an idea of kind of how it went for them.
We have oil and gas, paper and pulp, gas, power and water. We have pharmaceutical, chemical processing, chemical manufacturing. We help the customers configure, manage, and maintain their process to the best of their abilities so that they can get as much for their product as they possibly can. I do whatever research projects are needed so that we can look at upcoming technologies or existing technologies to see if they're going to be viable for use in our products. My interactions with Dell have increased over the last several years. We've worked with them for our cluster solution for virtualization. If you do a half rack, it's usually around 4.5 feet tall. You're going to put some UPSs in there. You're going to put a SAN in there. It's going to weigh approximately 40 to 80 pounds, depending on what model you go with and everything else. Then you're going to add 2 or more rack mount servers. They're going to weigh roughly 30 pounds. It usually takes me somewhere between 12 and 16 hours to rack a typical cluster. When we heard about the VRTX project, we jumped on it. We wanted to be part of it. With VRTX, it was really unboxing it, installing the base operating system, and within 3 hours, we had a clustered Hyper-V solution up and running. You don't have to worry about the cabling issues, and you don't have to worry about the IT expertise to set up a traditional cluster. VRTX, it really does come down to ease. It's more of open and play as opposed to open and build.
So, good example of looking for basically just a way to make multiple deployments simple. So this might apply if you're doing a lot of rollouts to systems in multiple departments. This is the kind of thing that actually applies pretty well. Here's the details on the VRTX server they were using. A lot of choices in this box. You can see this is in the case where it both serves as a tower as well as a 5U rack-mounted system. So there's a lot of interesting things here as far as expandability with storage options. Again, you'll see this in a number of the offerings where you have a lot of choices as far as the capacity of storage, the type of storage to deploy, as well as the adapters you would use. So choices of NICs, where you can select, you can upgrade the NICs, for example. A lot of times we talk about upgrading NICs on a storage server, for example, to give you higher throughput, incorporating RDMA, SMB direct capability to offload workloads from the Hyper-V servers. A lot of interesting stuff. I love the quote at the end, so I highlighted at the bottom. Open and play versus open and build, which is exactly the kind of thing we're looking for. The idea, clustering previously had strictly really been an open and build. It had been presented as a technology toolkit from the industry. And so one of the key messages today is that that's no longer true, is that this really is hitting the level of a mainstream technology. And I'll challenge you at the end where I want you to go with that with your own businesses. Okay, so that was number 2. Number 3, this is a storage application case study, and I call this the need for speed. So this is an interesting example. So this is, of all places, was the Australia Department of Defence. And this was a base in the capital of Australia, in Canberra. And it's actually, you can see there, it's the HMAS Harmon. It's kind of interesting. I had to look that one up because it's a ship. So it turns out, just a little aside here for those interested in this kind of thing, it turns out that in the Commonwealth, in the history of Britain, that the original naval papers required that anybody that was actually to be determined to working for the Navy had to be serving on a ship. And so they took on this kind of thing where they decided to start calling their naval bases ships and christening them as what they refer to as a stone frigate, this base that sits on it. So they actually are working on a ship. The ship just happens to be a base, and it's the HMAS Harmon. So there you go. Enough of that. So what's interesting here is that what they do is not, they might do some spook stuff, but we'll never know. But the basic workload they had was that they were the central operations center gathering data from a fairly large user base. You can see here over 100,000 users, 450 sites. And what their problem was is that they had to read and consolidate this data and process it real time within a very demanding window. So you can see here, they basically had a 5-minute window where they needed to ingest data, operations data, from all of these sites, and as well as then put it in the database and process it. So with that kind of a window, they actually needed some very, very high performance database transactions. All these tools basically were founded on the notion of gathering data, performing a very rapid set of database analysis on them, and then storing the data away and moving on to the next window. So what they needed to do is to use, this is why they ended up working with Violin to use their flash-based storage, because IOPS was kind of paramount in what they were doing. So they did a trial with the Violin system. You can see here a couple of fairly beefy servers operating, running the SQL database instances in the VM. You can see here the emphasis was on cores and available memory. So that for example, you can see here they had 15 separate databases, so they went ahead and decided to use a system where they could dedicate a core per database. And you can see in the setup, they actually dedicated files per database. So they could do this, but they needed the storage to back it up. And so what they ended up doing was using the newly released Violin Windows Flash Array. Again, this is the Violin memory storage coupled with Windows Storage Server on the 2-node controller that provides the high availability as well as the file protocol. So they did all this and set it up. What they ended up with was hitting over 1 million IOPS. And so this is actually, these curves are actually the ones that are more realistic. They're the ones that actually have Hyper-V loaded on the system. So this is running with the Hyper-V layer installed. And they actually were able to hit 1.2 million IOPS on bare metal. So what they found was that this system satisfied all of their needs as far as performance went, provided them by subtracting the overhead of having the additional gateway server be in front of the flash that they needed the performance for. They were able to simplify their deployments as well. So overall, very successful. And so they're now proceeding with the deployment of this for their mainstream systems. So it's a good example both of the general purpose nature of a cluster-in-a-box, storage as well as virtualization server, as well as my background has a lot to do with storage, so it kind of warms my heart to see the word Windows Server and high performance in the same discussion. So if you think those two shouldn't be associated, let me guarantee you're thinking 5 years plus ago. That the world has moved on quite a bit, and so this is a really good example of the fact that where a lot of work that's happened, both with our hardware partners as well as on the Windows side, to make this generally useful for even very demanding situations. Final, case 4. This is actually something close to home for TechEd. So how many people here have played with the hands-on lab area? It's an interesting space. If you look at it, it looks just like this picture here. There's an array of terminals that you can actually walk up to and do a self-service lab. Turns out that this is all provided by Whole Systems. And it's a set of equipment that actually, I'll show you a picture of in a second, runs off-site, and actually in Florida, and provides all of the VMs. So this is a case where they have an interesting problem. I call this one 10,000 plus VMs a day, every day. So they have the job in taking their system, which they actually use for general training events, and at TechEd it kind of peaks their requirements where any hands-on lab could run anywhere between 2 to 24 VMs, depending on the lab. You can imagine spinning up storage, Hyper-V servers, management servers, setting them up in a cluster. Depending on the lab, you could spin up a large number of these. So on average, they're having to deploy over 10,000 VMs a day. And each of these VMs only has to last about 45 minutes to an hour. And then it needs to go away, and the next person walks up and deploys it. Yeah, question?
How do these solutions compare to EMC's vBlock?
Sorry, EMC's, missed that last part.
EMC vBlock solution.
EMC vBlock. The question was, how do these solutions compare to EMC's vBlock solution? So EMC's vBlock is aimed at the same kind of part of the industry. So they're providing integrated solutions for running data center deployments. What you'll find in this one is these are more modular. So basically, you can buy something that's targeted just for the storage component, just for the virtualization server, and you can basically mix and match however you like. So vBlock is a targeted data center hoster kind of solution. We're actually looking internally. There's work going on, as you can imagine, as far as providing guidance on larger data center build-outs. Think of this as more of the smaller scale build-out for either smaller scale hosters or small, medium businesses. So what they found here is that they had a need for high availability, the ease of deployment, being able to build out these systems quickly and inexpensively. So their traditional one, this is actually their box, their wall in, I think, Tampa, Florida. They traditionally had used standard fiber channel storage of SAN, and had built it up with their Hyper-V servers. And what they found was that was doable, it worked, but it required the expertise of one person that was in the know, and they really wanted to do something to be able to scale out their operation. So what they did was they centralized their storage onto a DataON solution, in this case in the 9220, and moved basically all of their Hyper-V VM images onto this box, so they could quickly deploy each of the labs. You can see here they actually added took advantage of storage spaces tiering, so they have a hot tier and cold tier, and so they used basically SSDs and then used an external JBOD for the capacity. And by doing all of this, they basically were able to replace at really no cost, if anything, cheaper overall in terms of investment and cheaper overall in terms of deployment, their fiber channel setup. And it's a good example of, even though it's sort of a specific deployment, a couple of things that they found were interesting kind of byproducts of going this route was that these were individual clusters that were fast to deploy, and in that case, it provided individual fault domains. So you can imagine the demand. Somebody sits down in a chair in a hands-on lab or training environment. You need to bring up their session in a minute or two, and you have to do that consistently throughout the day. So a very strong requirement for availability on these boxes. So actually having multiple fault domains by deploying a lot of different storage modules in these individual clusters was an advantage. Sometimes people talk about, well, can you build these up into larger and larger clusters as a scale-up kind of a thing? And this was an interesting case where, well, sometimes thinking differently about the problem, you may want to look at the ease of deployment of an individual cluster, and having multiple of them actually gives you a little bit better tolerance to an individual unit failure. And the other thing, of course, that was interesting here was the expertise. So now they're able to branch out and use other people on their team without the kind of consulting knowledge of how to bring up a Hyper-V and fiber channel cluster and have them deploy systems. So it basically lightens the load on their overall cost of ownership. So kind of a win-win. And it's interesting to think of that sea of terminals you see out there in the hands-on lab. This is, in some sense, leveraging what people are talking about here at the conference. This is a little bit of kind of working with the cloud, where you have an interesting rack of equipment sitting someplace else that you don't even know, supporting a fairly demanding operation environment, real time, with availability as a cornerstone, and a cluster-in-a-box solution as the storage behind it. So interesting stories. I provide a slide here just to provide some backup information in case you want to look at it. Is there a question? Yes. Oh, the question is, I think for the hands-on lab example, yeah, the question is, for the hands-on lab, how many of the two-node storage clusters are they using? It's using multiple ones of them. And the answer is multiple, and I don't know how many. They're kind of doing a phased-in rollout of them. But here, Corey Hines, and there's some people at the hands-on lab that are around, just send them email, and they can tell you kind of where they're at in their rollout. But they're planning to use multiples of them. It depends on the scale of the rollout. But I don't know how many of them they use to support, say, TechEd. That would be an interesting statistic. Okay. All right. So let's see. One more piece I wanted to get to here is a little bit of talking about the future. So the cluster-in-a-box as a unit of availability provides, you can see, a lot of applications in the customer space. But one of the things that's interesting is the ability to use it in multiple in kind of a data center applications and in hosters. So I want to talk a little bit about the future, a little bit about where boxes like this can go, and if you use them in multiples, and something also about, as you hear about the cloud and the demands of the data center, also the different requirements that come up as far as the way people are thinking about what they need in an SLA. So first, a little bit about a data center. So I want to talk in terms of a Windows data center, but in a lot of ways, the requirements really are the same for any data center installation. So in some sense, like those attributes I was talking about availability, manageability, and scalability, those become kind of the overwhelming, overarching requirements when we're working with customers setting up hosting environments, on-premise, private clouds, and even in our own public cloud data centers. These are the things that actually drive the requirements of the system. And on top of that, there's also this need to implement these systems using industry standard hardware, volume hardware. Again, the economies of scale are such that you really want to drive out as much of the capital cost as you can. However, that being said, what we're finding is that the capital costs, and you might have heard that in some of the other discussions about data center build-outs here at the conference, capital costs are not necessarily the overarching concern of people building up these systems. Really, it ends up being operational. There's a trade-off between what you're willing to spend to build out a system and kind of what you're needing to spend to be able to keep it running and keep it operational and provide that SLA that I talked about to your customer base as far as uptime of their VMs, capacity, being able to monitor to make sure that they're getting the memory, the storage capacity, the throughput that they're expecting for their workloads. So what you see here is the typical module. So between the compute and the storage and the networking, you add on the management, and you have basically the typical pieces of a data center or hoster deployment. So the question here is now, well, where does cluster-in-a-box fit, and what do you do for storage? Does the technologies that we're talking about for cluster-in-a-box fit into this environment? And so there's been a lot of work happening at Microsoft as we've been working with the industry, as you can imagine, both in our own data centers as well as investigating how to support the hoster market, looking at this stuff. And so what we found about, particularly for storage, is there's some demanding requirements that you have to consider when you're looking into this kind of environment. The first one is calling N+2 redundancy. There's the idea that when you're providing this kind of SLA, it's paramount to not have to treat a failure of a piece of equipment as an exception or an emergency. That one of the strongest requirements we've heard has been that a piece of equipment failure needs to be treated as an everyday occurrence, that it needs to be treated as handled by planned maintenance, that a pager cannot be expected to go off, or a text message can't be expected to be sent with an hour response time in the case of a standard single piece of equipment. So N+2 basically says that if any single piece fails, even a shelf of storage, or a processor, there needs to be additional redundancy in the system so that you can survive that and still be backed up and be able to replace that equipment failure as a planned maintenance event. So what we found is one sweet spot for storage tends to be 4 nodes. 4 nodes, 4 JBODs tends to satisfy that. It gives you the ability to give the performance you need, because remember, when you fail over, you also you need to have the capacity to do the workload remaining. But it also gives you the ability to survive a JBOD failure. So we've been looking at different configurations, and for example, with storage spaces, we're able to give it cabinet-aware configuration, so that if a shelf goes out, we use 3-way mirroring so that we can basically survive a shelf, as well as maintain the redundancy needed to be able to continue operation until a planned maintenance event. At the same time, you have to be able to guarantee performance, and so incorporating SSDs is really important. Being able to, all the things you heard about in terms of SSD configurations, even in the DataON system here, their new system that is their 24-drive box they're shipping with the HGST SSDs provides a very great hot tier layer. In this case, you need to use the same kinds of things to provide that kind of overall performance. Now, the last bullet here in many details is probably one of the most important things that I think any of you would understand having to build these systems, is that while all the functionality is now there, the devil is absolutely in the details. Hooking up the various pieces of equipment that have all the proper specifications for throughput and support all the proper interfaces for management. These days, typically what you'll find is if you do that, almost with 100% probability, it won't work. Or at least it won't meet anything near what your specs are. And it's not to say that the individual components don't work. What it's saying is that there's interaction issues and scale and performance issues that need to be figured out. And this can be anywhere from tuning firmware, getting the right version of drivers, getting the right configuration on your network, to some even more intense things. For example, choosing the right disk drive that needs to scale to the level that you're accessing it across such a system. All of these things take a lot of work to figure out, which is why sometimes if you get a winning combination, you simply repeat that configuration over and over again because you know it works. This was actually one of the fundamental reasons why we had to work with the industry to get Cluster-in-a-Box going, because in order to really solve these problems, there really isn't any other way besides getting a tune set together, pre-configured, that you know it works, and then shipping that as an end product. So in some sense, if you think Cluster-in-a-Box, what it does is it takes a layer of the availability layer of this problem, does exactly what I'm saying. It deals with the cables, the matched components, the processors, the communications, and gives you an integrated, tested system that you can easily deploy. So at the data center level, we're finding, of course, it just grows from there. And so when you're using these kinds of components, it's important to understand how they're matched and how they're configured. So there's a lot of, in terms from the customer base here, if you're looking to deploy, say, a data center, a hoster kind of cabinet, what you're really looking for is proven capability, interactions that's been tested and pre-configured. So, and a lot of that simply just takes time. And so one of the future requirements here is to see more systems coming out that are integrated at this level. And so what we're expecting to see in the industry are more partnerships between companies that are providing this, more integration, for example, in these kinds of systems. These Cluster-in-a-Box systems, we're expecting to see roadmaps that include tested integrated configurations that show scale out to multiple nodes, all those kinds of things that you would otherwise have to debug and grow yourself as a customer base. So again, the question about VBlock is a good example. VBlock is an example of a defined configuration that's available for users to simply install and go. And we're seeing that as more of a general trend in the industry, actually. While the expertise exists, and a lot of people are seasoned professionals like yourself that know how to do these things, the question is you don't really want to do these things. You don't want to have to spend a lot of time and resource to deploy, define, purchase, integrate, and deploy a set of systems. So what we're seeing actually is the demand is not so much from a lack of knowledge, it's more from a lack of time and resource. So what you really want to do, the demands we're getting from our customer base is to deploy these systems, be able to purchase, and things like time from purchase order to delivery on the dock to up and running in the data center are becoming key metrics for vendors. And so that's why you're seeing some of these integrated solutions show up as kind of some of their key SLAs themselves as a system vendor are related to their ability to deliver running systems in a certain window of time. And so that, along with the ability to operate the system with low bandwidth, non-emergency staff, thus the redundancy requirements, are becoming almost the paramount attributes that people are looking for in overall systems. If you think about that, it's one level up from what we're used to, from decades previous. A lot of times servers would be sold by simply a list of functions and hardware. And today, it really is all about the integrated solution. And so Cluster-in-a-Box is a start to that. And we're now looking at build-outs that are even beyond that to help support the data center. So talk to your vendor about this space, see what their plans are for helping do it. If it's interesting to you, give us feedback here at Microsoft as well, because we're something we're constantly working towards. So to sum up, what we have here is the story from storage to the cloud. Availability, what I've told you is that availability started out as something that needed to be added as a cornerstone for us to be able to build a data center story and a cloud story at all. Started out in the storage realm, grew to the server, and now we're into next generation building blocks and some innovative new pieces of equipment that you can use to build anything up to a data center. The cloud has increasing requirements Some of the key attributes there are availability, manageability, scalability. These are all very strong value adds that partners vary on in terms of what they offer. But we still see it as kind of this wave is giving a kind of a foundational building block for everything you're going to see now moving into the cloud. So whether it's a public cloud service that you're looking to support or in your own shop, where you're the provider, you having to provide that, these kinds of systems we think can provide you a very simple way to get there in a very efficient, inexpensive manner. So there's a number of other sessions ahead of us at the conference here that I encourage you to go check out. Anything from the clustering compute side to the virtual networking. I've listed some of them here. So you can go learn more about the tiering storage spaces features that I mentioned. A lot of interesting stuff that you're in the right place to go find out more about them. And there's a couple of hands-on labs, some of these instructor-led hands-on labs that will actually give you ability to try out some of these configurations for yourself and get a feeling for what it means. Now everyone here will know a little bit more about what's behind the hands-on lab as you get there. So think about those systems chugging away in Tampa, Florida, so providing all the storage. I'll be available in the Microsoft Expo area. So I actually have a slot just after this session later this morning, as well as on Wednesday. So if you have any other questions, you can definitely find me there. And let's see, I also wanted to then say I'll be putting up the survey QR code in just a second, so please fill those out. Absolutely, we depend on that feedback to help make this a better conference. And then just finally, I want to give a shout out to the partners that help make this so, since it's a cooperative effort we do here at Microsoft to produce these kinds of systems. So thanks very much to DataON for bringing up these systems and having this family of boxes. Thanks to Aaron Marks, who's here, for providing all that great data about his case study that'll hopefully give you the opportunity to really, nuts and bolts evaluate the kind of job that needed to be done for your area. You can check out the booths from DataON, Violin Memories, as well as Dell for giving their information and their permission to use their information from their case studies. Definitely go check them out on the floor. And finally, that last question I wanted to ask you. So I've been asking this is the third year running, is well, why isn't your business highly available? I want to hear if there's any reasons left. I think at this point, you'll be hard pressed. It's simply a matter of looking at the next generation doing it. So thank you.